Okay, in this video, we are going to talk about probability. There's actually going to be 2 videos. This first video is just going to be like the activities we would have normally done in class. Again, this is another video that is a lot of fun in class, and it's probably not nearly as much fun to sit and watch, but again, this is where we're at. So I have uploaded a packet on D2L, and it looks like this. So it would be beneficial to have this out or to print it out, and if you have like some tacks or some pennies so you could like play along, feel free to do that. For this we need like these specific types of tacks, like the flathead tacks. Okay, but you can also just watch me do it. It's not nearly as much fun, but feel free to do that also. Okay, so we're going to look at the second page on, well, I guess it's the back of the first page. On this packet, and we're going to do a few different experiments to talk about probability. So it says that suppose someone wanted to bet that a tack would land with its point up when dropped on a hard surface. Would you accept the bet? Before you wager any money, try the following experiments. Take 10 identical tacks and drop them on a hard surface. Count the number of tacks that land point up. Do this 10 times and record your results in the table on the next page. So if we were in class, I would give you each a set of tacks. We would do this all together, but since we aren't all together, I have 10 tacks here, so I'm just going to drop them, and we're going to see which ones land point up. So I have 1, 2, 3, 4, 5, 6 land point up and 4 land point down. So on trial number 1 out of 10, the number with points up, there were 6 with points up. Okay. So let me do it again. So this time, that one went over there. It is 1, 2, 3, 4, 5 are point up. Okay, let's do it again. This time it is 1, 2, 3, 4. We're doing this experiment 10 times, so we have a total of 100 trials to look at, 100 tacks that have been dropped. So we have, oh, that's me about 1, 2, 3, 4, 5. This time 1, 2, 3, 4, 5, 6, 7. One, 2, 3, 4. Sorry, this might not be very funny. Fast forward through this part if you want to. 1, 2, 3. This time there was only 3. One, 2, 3. So again, 1, 2, 3, 4. Okay, so we did that 100 times because 10 tacks were dropped 10 times. It's 100 different trials. It says out of the 100 tacks you dropped, how many landed point up? So we need to add all this up together. Let's see, I'm gonna make some 10s. So 6 and 4 makes 10. 5 and 5 makes 10, so that's 20. 7 and 3 makes 10, that's 30. 6 and 4 makes 10, that's 40, so 44. So 44 out of 100. Okay, on the basis of this experiment, explain why you would or would not accept the bet. So again, the bet was that the tack would land face up. Okay, so if I had 44 out of 100 that landed face up, would you accept that bet? Okay, so think about that for a second. Probably you would say, maybe, maybe not. 44 out of 100 is not quite a 50% chance, right? Because the way that we write probability, you can look at it here, the number with point up is 44 out of the total number dropped is 100. Okay, so that's the fraction 44 out of 100. I can make a percentage or a decimal out of that. The decimal would be 44 hundredths, and the percentage would be 44%. Okay, so probably not. I wouldn't necessarily, because I would probably lose money. No, I wouldn't take a bet. The odds aren't in your favor. 44 out of 100 is pretty low. More than likely to land point up. I'm sorry, point down, because we want it to land point up. Likely land point down, so on and so forth. And if you kind of look at my numbers, I think I was rolling it funny. I think I was just dropping them versus like actually rolling them. I don't know. I feel like I didn't do a very good job at the beginning. Usually this number is actually lower than 44 in previous semesters. Okay, so 44% is our probability here. Again, and we'll write this down in the next lesson of like exactly how to write the probability, but the probability is the number of successful outcomes you have out of the total number of outcomes. So we had 44 successful outcomes where it landed point up out of 100 different outcomes. Okay, so about how many tacks would you expect to land point up if you dropped 300? Okay, so we can use a proportion here like we have before. So 44 out of 100 would be the same as what out of 300? Okay, so to get from 100 to 300, I multiply by 3. So I'm going to do the same thing here. Multiply 44 times 3. And that would be 132. 132 out of 300. Still waking up this morning, so let me double check my math here. Make sure I did it correctly. 44 times 3. Yes, it's 132. So 132 out of 300. Okay. What is the experimental probability that this type of tack will land point down? Okay, so if 44 of them landed out of 100 landed point up, how many landed point down? Well, you could count 4 from this one, 5 from this one, 6 from this one, 5 from this one. Or if 44 out of 100 land point up, then that means 100 minus 44 would be 56. So 56 out of 100 landed point down, or 56%. And how is this related to the probability in part B? It is 100% minus your other percent. So it's 100% minus the 44% equals the 56%. Because if it didn't land point up, then it landed point down. Those are only two options here. Okay, the next thing we're going to do is, it says games of chance like the following are common at carnivals and fairs. A penny is spun on a square grid. If it lands inside a square, you can win a prize. And we're going to do, it says compare the diameter of a penny with the width of the 2-penny grid. Do you think there's a better chance that the penny will land inside the square or on a line? Making conjecture before you begin the experiment. Okay, so here's the experiment. We have this grid and we're spinning a penny to see how many times it lands inside the square. So we're using, I find it, this card right here for it. Okay, so let me get my penny out. So here's the size of the penny. It fits pretty well in there, right? So do you think this is a fair game? Do you think you can land the penny in the grid more often, or will it land on the lines more often? Okay, and that would just be something that you would decide. So it says spin the penny 24 times and tally your results below. If we were in class, this would go a whole lot faster. I may only spin it, I think I'm only going to spin it 10 times just to save a little bit of time and so you don't have to sit here and watch me spin it this many times. Oh, and the fact that I can't spin it very well. Let's try again. Okay, so that one landed on the line. So on a line would be this one. I'm doing tally marks. Okay, let's do it again. Uh-oh. Uh-oh. This is probably super fun watching me do this. That one landed in the square that time. So we're gonna put it in the square. On the line, put a tally mark on the line over here. That's a good one, but it did not. Oh, come on. I didn't practice this. That one landed in the square, so we're 2 for 2 so far. Oh. Let's try it again. There we go. And that one is in the square, is not actually touching the line if you look at it really, really close. So we're going to say it's in the square. Oh. Oh. That one's on the line. In the square. This is funny how I'm getting so many in the square. I feel like that one's gonna be on the line. Ooh, maybe not. No, it's on the line. So 2 more. I'm at 4 and 4 right now. Oh. Line makes 5 on the line, and no, that's not good. Y'all are probably laughing at home. I would be too. That one's on the line also. Okay, so I ended up with 6 on the line, 4 in the square. And again, this was out of 10 because I didn't want to sit here and make y'all watch me do it 24 times. Okay, so based on your experiment, compute and record the experimental probability that the penny will land inside the square. So inside the square is how many successful times did we get it in the square? 4 times in the square. How many total times did I spin the penny? I spun it 10 times total. So 4 out of 10, which would be 4/10, which would be 40%. Okay, so this is the part that I feel like is the most eye-opening, and I really would like for you to do this part at home. Okay, so if you can print this off and use a penny, that would be really beneficial for you to do that, but I understand that you may not have that option. Okay, so it says the length of the penny of the side of a square is twice the diameter of the penny. So that means that you can fit 2 pennies inside the square successfully without touching the lines. Okay, so it says which of the points to the left labeled A, B, and C will be winning points if they represent the center of the penny. So if A was the center of the penny, would that be a winning point? Yes, because it would be inside of it. So A would be a winning point. If I put the center of the penny on C, would it win? Yes, it would also win. What about B? If I put the center of the penny on B, that would be a line. So it's just A and C. Okay, so this is the part right here I would like you to pause the video and do. Shade the region of the square in which the center of every winning penny must fall. What fractional part of the square is in the shaded region? This is the theoretical probability, okay? So, real fast, before we do that, before you pause the video and do that part, let's talk real fast about experimental probability versus theoretical probability. Okay, so experimental probability is what actually happened, okay? So it's the probability that actually happened in an experiment. So this is based on the results of your experiment. Okay, and this is also sometimes called empirical probability. I spelled that wrong. Empirical probability. Okay, so theoretical probability is in theory probability. Sorry, I can't talk and spell at the same time. Theoretical probability is in theory what should be actually happening. So this is based on theory. So the best example of the difference between these two is if you're flipping a coin, heads or tails. What's the theoretical probability you're going to get heads? 50%. What's the theoretical probability you get the tails? 50%. If you flip a coin 10 times, are you for sure going to get 5 heads and 5 tails? No, you may get 6 and 4. You may get 2 and 8. Like, you just never know what you're going to get. The 2 and 8, 6 and 4, what actually happened is experimental or empirical probability. The 50%, that's theoretical probability because there are only 2 options there. You got to get 1 out of 2 there. Okay, so this is finding what the what the theoretical probability is. We already found the empirical or experimental probability of 40%. So in theory, what should happen? So take a second and see if you can shade the region of the square in which the center of every winning penny must fall. Okay, so I'd like for you to pause the video here and see if you can do that. Okay, so if you're back from doing that, I hope that you figured out that here's the center of this penny right here. Technically, it needs to fall in all, like on this side of that line. If anything falls on that side of the line, it's not going to work, right? Because then the edge of the penny is going to be on this line. Same thing for this one. It needs to be, can't be out here. It's got to be on the inside of that line, right? And if you'll notice, this kind of splits it into 4 parts technically, and 2 parts in the middle work. Okay, I can do the same thing on the other side because this is just a square. Okay, so I can do the same thing here. It can't fall up here on this top part. It can't fall down here on this bottom part. It can only fall in the middle here. Okay, so let me shade in the boxes that it can actually fall in. It has to be to the right of this line, below the top line, to the left of that line, above the bottom line. So this little square right here. Okay, the theoretical probability is how many boxes are shaded here. Well, it's kind of hard to see, but 1, 2, 3, 4. 4 boxes are shaded out of how many total boxes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 total boxes. So 4 out of 16, which is reduces to 1/4, which is 25%. Okay, so the theoretical probability here is 25%. I actually did pretty dang good this time. I'm actually really bad at this normally, and maybe it's because I didn't do a very good job of spinning them, so maybe it wasn't super fair that way. But 40% of when you're early supposed to get 25%, we did pretty dang good. Okay, so is this a fair game? Is there a 50% chance of winning? No, this is not a fair game. There's only a 25% chance of winning. Okay, so if you look at the next page, I've got my pages all mixed up. It says, what about the 3-penny one? Okay, so what about this one? These are much bigger squares. There's a lot more area for my penny to fall here. So if I could ask for you to do the problem again, if we were in class, I would have you do it again. I'm not gonna make you watch me spin that penny again. Let's just do the theoretical probability here, okay? So theoretically, what should be, is this a fair game? Can I get a higher percentage, closer to 50%? So again, I'm gonna do the same thing. I'm going to draw my lines here for my center of my pennies. And you have more lines this time. It's gonna be the same thing on the sides here. Get a 3rd penny. So this is the center of the penny that I'm drawing the line through. I'm also doing the edge so that like my squares are all the same, so I can find the fraction here. Okay, so this time I can be, I'm going to shade up a lighter color so you can still see it a little bit better. This time I can be anywhere inside this box. This is where the center of the penny can land. Okay, so what is the theoretical probability for this one? Well, we're going to count our boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 total boxes out of 1, 2, 3, 4, 5, 6 times 6 is 36. And this reduces to 4 out of 9. Yes, that's right, 4/9. And that as a decimal is, I'm running out of room, 0.44 repeating. So that would be about 44%. Okay, so is this a fair game? Technically, no, it's not a fair game. And because you can only win 44% of the time, theoretically. So 44% of the time, you win. Is it more fair than the last game? Yes, it's definitely more fair than the last game, but this might not be a game you still want to play because technically the odds aren't in your favor here, okay? Okay, so there are a couple other activities here, and if you would like to read through those, that would Might be, if this is something you enjoy. Lots of people really enjoy like games of chance and that sort of thing. There's one about a card, about cards that have A's and B's on it. And then, get my stuff mixed up. And then there is another one about sweaters. Okay, so grabbing a sweater, and here's another one about rolling dice. So those would be some fun activities if that's something you choose to do. We're gonna stop this video here, and then I'm gonna come back on the next video, and we're gonna talk more about like actually doing probability problems. Like if I give you a situation, let's find the theoretical probability, that sort of thing.